Hello everybody, we are going to introduce you the new module of AR, AirNavCAD from AirNavCAD. We developed a new module. It's easy to build AR procedures. In this case, we have an example here in Chile, and this is the procedure. Start in SEPAN and finish the initial segment in login. Now the login to the CF084 is the FAS segment, and from CF084 start the MIS approach. So it's very easy procedure. So and this module is similar to the PBN, see the start wizard, but we improve both wizards in similar way. So we have low data and new data. New data is when you don't have previous information data created another ARMP. So in this case we are going to click new data. Okay, this is the new data, and we are going to build an initial approach. We select the CAD. We are interested in this case CAD D. This is similar to the PBN. We have the trap, but in the initial approach is 00, because in the next wizard we are going to put the altitude. Okay, so we click finish, and this wizard is similar to the previous version, but is different because now the workspace is available. In the other wizard the workspace was not available. So in this case we are going to introduce the points, the waypoints. In this case we have SEPAN. This is SEPAN, bodies, CF246, tunnel. We are bigger this wizard. Tunnel CF119. That here start the ready to fix, and now we have to put the center of the ready to fix. Now the final point is login. This is login. This is the RNP now miles. In this case we can find that information in the table of the procedure, or if you don't have a kind of procedure, normally the first point is 119 miles and the rest is 03 or 1. It depends on your specification. In this case, in this chart is 03 every part of the procedure. In this kind of here AIC 6 we can find the points SEPAN, bode, CF, tunnel and login, and we see here the specification, and 103 to the final, and this is the altitude of the points. So now we have to select introduce the altitude of any points, like the PBN star and MIS approach. We introduce in the initial segment just the altitude of the points, the RF, and the last point is 8 and 90 feet. This is the center, but it's not necessary to put any kind of information. Just the important point is the center, the point, the waypoint. The back angle that you can edit by default is 25 initial approach, and the IAS, maybe the velocity is limited in this case, only in CF 1180, that in this case is SEPAN, bodes, is in the ready to fix here, the velocity is limited to 210 knots. Okay. Now, different from the previous version, instead of click finish here and select the points here, we have the points, you can include it here, the waypoints. You can include here manually in format UTM or degrees, minutes and seconds, separated with a comma, latitude and longitude, or X and J, X and J. Or just click on workspace. For example, in the first point, we click in the first point, and the waypoint is loaded. The next point, borders, first one, the next one, tunnel. You can see we can make zoom out, the center to the radius to fix, and the last one, the login. And if everything is okay, we can save the data to change, edit any of the parameters like altitude or tune altitude or back angle, or include, you can edit another point, because you can edit everything or delete it what the point that you are interested. And we click draw, and we have and save in the workspace the procedure, whatever you want. And now you can load in here. You can load that the part initial approach, and edit. You recover this wizard, and you can edit everything from here. And this is the area of the first segment. Okay. Also, here in the output, we got the distance of stabilization between the segments, between the points. We have, if we meet the requirements, if the longitude is bigger than the specification of the points. And also we have here the points, the type, the altitude of the area. In this case, it has to match to this kind of altitude. The specification, the velocity that you can see here is 210 for this point to the radius to fix. The wind that is calculated to that altitude with the formula of OASI, the back angle and the turn angle. Okay. So we can close here, and now we are going to create the FAS. The FAS can include a radius to fix. For example, we can include this kind of radius to fix, but in this case is just straight ahead. Okay. You can. We are going to finish in CF084. So, for example, we are going to put here the same error segments, new data, and we have to put here FAS segment. CAD, we are interested in D, and here we have to include these parameters that we can find in the chart or the parameters we have about the airport. In this case, -5 degrees, for example, RDH 49 instead of 15. The altitude of the threshold in this case is high, 7431 feet. The estimate OCH, in this case this is the estimate OCH. And now this is how to calculate the high loss from velocity if you don't want that the default value of KD, that in this case is 49 meters, but corrected with altitude BPA. You can include that high loss from this velocity for another cases. And also we have here another parameters that are included in the 9005 document of AR that is included in that document. So you can edit is in any case you find is different from your case. For example, the 25 maximum bang angle, maybe in this ready to fix you want to increase that maximum bang angle to 30, for example. Okay, we click finish and we include the points, in this case log m, this one, the wrong way, and finally this one, for example. This one is 0.3, everything is 0.3 or 0.15, depends. The last one is 1. We can find that information here in the I close here in the procedure. We can find that information here, that the point CF084 is 1. The last one is 0.3, 0.6, and it could be 0.15, 0.15, and or 0.3, 0.3. The BPA is, in this case, is 2.7. Okay, we can also here see. Okay, in the FAS, the previous of the last point is the wrong way, because always you have to indicate the final point. It could be the shock or another point. It has to be another point different from the wrong way. For example, is this case, this is the first point, log m, wrong way, and the CF085, but the last the wrong way, you have to include the altitude of the wrong way. To calculate, the program is going to calculate the altitude of this altitude of log n with the BPA, etc, etc. But I believe I put 3 degrees, not 2.7. But for any cases, you have to, by default, you try with an altitude, a BPA of 3 degrees. In this case, I think I don't change that data, but to create the example is okay. So, as before, we can save the data to edit parameters like the BPA, and here we have include the points log m. We have to make zoom in to click in the correct point, the wrong way, and the last one is CF0. So this creates this kind of also the parameters is corrected. In this case, the altitude of the airport is bigger than 900 meters, so the high loss is corrected, and you can save. In this case, FAS is save FAS. And also here in the output, we can see that the BPA is 3 degrees. CAD D, the temperature, the FAS gradient, the distance of the BAB, where the FAS is calculated, the delta ISA, delta H, the minima temperatura VP effective is 2.9, the minimum of 2.5 degrees is minus 43. The maximum to 3.5 is 44 degrees. The high loss by default is 52 meters because it's corrected with high altitude. The XZ at that high loss is this one. the shot at that OCH that is 250 fits is this kind of shock. Okay, so we can recover with the load data, and we find the FAS. You can see we can recover all the data and the waypoints, the same information as before. You can edit any point that you require, the specification, and etc. etc. You can edit the bang angle, the velocity, etc. etc. Okay, now we have to include the misapproach segment. That here is this ready to fix, starting the shock. We can put this shock from the threshold. We are going to suppose that the shock is the same point as a sample in the same point as the roadway, but the shock is in this distance from the roadway. For example, here, this is the shock. So, utilities panels, utilities AR, new data. We select misapproach. Again, we select the category. By default, the track slope is 2.5. The altitude of the turns are calculated at 7%, as the document 1990-05 tell us. And you can edit also the elevation. This is for to calculate the wind in the RF ready to fix turns. That depends on the elevation of the aerodrome. 7431. You can include other wind, but in this case, as 1990-05 tell us that the wind of the ready to fix is calculated with the elevation of the airport. We click finish, and we include here the points. Shock on map, it depends of your case. In this case is a turn at point, could be turn altitude, but the turn altitude start in the MPT. As I see in another examples of Chile. Yes, this point CF05, that is ready to fix. The next one is CF34, and the last one, that is PAMIC. This point is calculated with the specification 111, and this one is the first one, the shock. What else? The velocity, the altitude of the shock, that we can suppose that is the altitude of the aerodrome, for example. So that altitude is going, the rest of the altitude is calculated to the nominal track. Okay. Just put the altitude of the first point, the shock, MPT, etc. Depends on your case. You can save data, etc. etc. And the bang angle is 15 degrees, that you have to edit it. 15 degrees, don't forget. And we click in the points. The first point, the shock, that we are going to suppose that's in the way. The next one, the ready to fix, is this one. This one is the center, that I forget. This is the center. This one is this point, CF340, 14. And the last one that we have to include is PAMIC. That PAMIC here, PAMIC. So this one is also 15 degrees of the bang angle to misapproach. The altitude of the first point, that is shock. And what else? The velocity is, there is a limitation. It has to be included on the points or in any part of the etc. etc. So And also we had to include the load the OAS that we built before. In this case we have to select the OAS and load the OAS. You can see that the draw now is available. If you don't select the OAS, this button is not available. Also the output tells you that the OAS are selected. You could select it any part of any polyline of the OAS. Okay, and you can save and edit the parameters in the next step, etc., etc. And you click draw. Attention, the back angle calculated in the radius to fix, this one, 20, with radius 5 nautic miles, this radius, exceeds the maximum of 15 degrees, this one. So be aware, it is radius or velocity, or be aware that it's 20 degrees, so, okay. And you get this kind of areas. And also here we get the stabilization segments, the longitude of the segments, and the specifications distance. So in this case, mean requirements. And also we have here the data. The data that we have calculated, the altitude of the area at 7%, altitude nominal at 2.5, the specification, the velocity, the wind, in this case the radius to fix, is calculated to 40 knots, depends on the altitude of the aerodrome. In this case the maximum is 40, I think. The back angle that by default is 15 degrees, but you can see the message that in here at that velocity and that angle is 20. The back angle is 20, so be aware of that.